So, everybody with me? Today we are looking at polynomials, zeros, and factors. So we're going to be looking at how the zeros, which are our x-intercepts, relate to the factors in our polynomials. So, if I look at this equation right here, f of x equals 5x squared times x minus 4 times x plus 2 times 3x minus 5. What values of x make f of x equal to 0 for this function? Okay, so what's a number I could plug in for my x and it would give me 0? What? I heard 1. 0? Okay, if I used 0, f, put my pen on here, f of 0 would be 5 times 0 squared times 0 minus 4 times 0 plus 2 times 3 times 0 minus 5. And that would give me 5 times 0 squared would be 0. This would give me negative 4. This part right here would give me positive 2. This part right here would give me negative 5. And what would that equal when I multiplied all those together? It's going to be 0, because anytime I multiply anything by 0, it gives me 0, right? It doesn't really matter what these numbers are here, because 0 times anything gives us 0, right? It's your easiest multiplication tables. No matter how bad you were at your multiplication tables in 3rd grade, you probably got your zeros right, I hope. If you didn't, then we're really in trouble. So 0 is one of the answers. So x equals 0 is one of the answers for that. There's more. What's another number that would give us 0? Okay, if I plugged in 1, let's try it. I'd have 5 times 1 squared, and then 1 minus 4, 1 plus 2, and 3 times 1 minus 5. 1 squared is just 1, and if I multiply that by 5, I'll get 5. 1 minus 4 is negative 3. 1 plus 2 is 3. 3 minus 5 is going to give me negative 2. So 5 times negative 3 times 3 times negative 2, is that going to give me 0? No, that one won't work. All right, somebody else, another one that might give me 0. What do you think, Kaylee? 4. All right, if I do 4, 5 times 4 squared times 4 minus 4 times 4 plus 2 times 3 times 4 minus 5. Okay, that's going to give me like 5 times 16 times 0 times 6 times, let's see, 12 minus 5 is going to give me 7. All right, what is 5 times 16 times 0 times 6 times 7? It is 0, because if any of those numbers in there are 0, we're going to get 0 when we multiply them all together. So Kaylee is right. 4 is one of the answers. Okay? You might be starting to see like a pattern of how you could figure this out. You might know another one. 8. 8's not going to work. I could get there. Negative 5's not going to work. What do you think, Keely? Negative 2. Let's try it. The fact that I'm trying it should make you think, oh, it probably works. 5 times negative 2 squared, negative 2 minus 4, negative 2 plus 2, right there's your key, right? And then 3 times negative 2 minus 5. So that would be like 5 times 4 times negative 6. Negative 2 plus 2 is 0. And then this is going to be negative 11. Right here, what is 5 times 4 times negative 6 times 0 times negative 11? It is going to be 0, because one of your numbers that you're multiplying is 0, right? So x equals negative 2 works. There's one more. It's not 5. You were kind of following the pattern, and that makes some sense. But this 3 right here messes us up because if I plug a 5 in right there, 3 times 5 would be 15 minus 5. That would give me 10. It would not give me 0. Anybody know? It's not an easy one. It's not a whole number. The other one that's going to work, and I'm not going to work through how to do this just yet because we're going to get to that, is x equals 5/3. And the reason that 5/3 works is because when I plug it in right here, 3 times 5/3 minus 5 is going to give me, if I multiply those together, it's going to give me 15 divided by 3 minus 5. 15 divided by 3 is 5. 5 minus 5 is 0. So 5/3 works as well. The other ones are easier to look at and find. That 5/3 is a little more difficult, but I think when we see it, you'll see that it'll be a little bit easier to find the answer. So, a conclusion that we're going to make: if x minus c is a factor of a function, then c is a 0 of that function. So if you have your function already factored out, this one was already factored, right? It's all broken up into its parentheses. If any piece of that equals 0, then that's going to give you a 0 for the function. Okay, and it ends up being the opposite sign right here, that positive for the -2. There's a 0 with this right here. We're going to look at some more of these. Okay. So, if I have a problem like this, f of x equals 3x minus 2 times x plus 7 times x minus 4, and they say, what are the zeros of this equation? Okay. First of all, you can use Desmos for this, and I'll show you how here in a second. But if it is already factored, solving it by hand is really easy too. I would probably, if I were doing this, I would just solve it by hand. Although I might check it on Desmos. So if we're looking for a 0 of this function, we just have to set all the pieces equal to 0. Because if any of those pieces are equal to 0, the whole thing is going to be 0. This is called the zero product property. It's a really important part. It's the reason we learned to factor in the first place. So we'll just take 3x minus 2. We'll set it equal to 0. We'll take x plus 7. We'll set it equal to 0. And we'll take x minus 4 and set it equal to 0. And what you're going to be left with here is going to be like pretty easy 1 or 2 step equations to solve. In fact, a lot of times these right here, people don't even write them down. They just do that part in their head. So for this first one, it is slightly more difficult, but it is still just a 2-step equation. So Joseph, if I want to solve that equation, what do I need to do first? Nope. I'm just trying to solve it, so I'm just trying to get that x by itself. So if I'm trying to get that x by itself, I got to get rid of the 3 and the 2. Which one do I get rid of first? Nope. 2. 3's right beside it. We got to wait. So we got to add that 2 like that. And so we got 3x equals 0 plus 2 is just 2. And then what would we have to do with the 3, Joseph? Very good. We'll divide by 3. And for that one, we're not getting a whole number. We're just going to leave it 2/3. A lot of times the answer choice is going to be left as 2/3 if it's multiple choice. Okay. Jeremy, how do I solve the second one? Just subtract the 7. So x equals -7. And Trinity, how do I solve the last one? Add 4. So x equals +4. And a lot of times kids will just do those like last 2 in their heads. They'll just you just change the sign. If there's a number right here it's not quite just changing the sign. You might want to write that one out. So now you can also do these on Desmos. So let's open up a tab for Desmos here. That one. I'll drag it over to the side. So if I graph the original, if you look at your x-intercepts, they are at -7. They are at 0.667, which is the decimal approximation for 2/3, and then at 4. Right. So you can also graph and find your x-intercepts as long as they are real numbers. We will see a few imaginaries. Okay, questions? All right, let's try another one. These are already factored out, right? You got all your parentheses, so it's already factored out. You just need to set each piece equal to 0. So I'm going to say 3x equals 0, x minus 2 equals 0, x plus 3 squared equals 0, and 2x minus 3 equals 0. So, Josiah, how would I solve that first one? I've got 3x equals 0. What would I do there? Good. We just divide by that 3. We're still going to get 0 for that. For the next one, Keely, what would I do on that one? Just add that 2. These just change the sign, right? You could almost do them without writing anything down. Victor, how about the next one? I got a square. How do I get rid of a square? Who can help him out? How do I get rid of a square? Square root. That's it. We square root. It just gets rid of the square over here, and the square root of 0 is 0. So you don't really do, it doesn't change much. And then, Victor, what do you have to do? Then you subtract that 3. So if you have like a square or a cube or something, you're just going to like root the sides, and the root of 0 is always 0. So it is going to be just itself pretty much. That should be an equal sign right there. All right, so we got 0, 2, -3. This last one is a little bit trickier, but it's not too bad. Alex, what would I do for that last one? Add the 3 first. So 2x equals 3. And then what do I do, Alex? Divide by 2. Good. And so we'll get x equals 3 halves for that. Okay. You can always graph it, look for the x-intercepts, you're going to get the same thing. Except for it will give you decimals instead of fractions, on like that 3 halves. All right. Okay, there is something that we must recall how to do. It is quadratic equation, so this is a Math 2 topic. -b plus or minus square root b squared minus 4ac all over 2a. That is your quadratic formula. Did you guys sing a song or something in Mr. Brown? So what kind of song did he sing? It was like a rap song. Yeah. Yeah. I've heard several versions. Miss Ball used to always do like an army chant, like opposite of b plus or minus square root. That one, her Sesame Street version. So if you don't know the quadratic formula, there are lots of songs that you could learn the quadratic formula with. But whenever we're doing quadratic formula, we always have to have our equation in the form ax squared plus bx plus c equals 0. Okay? So in this problem, we almost have it perfect. It's equal to 0. If it's not equal to 0, you're going to have to move some stuff around. It's got to be equal to 0. I don't have a number in front of my x squared, but what number is there? It is a 1. All right. So for this, A is going to equal 1, B is going to equal -5, and C is going to equal -8. And so if I want to solve this using quadratic formula, I'm going to do x equals -b. So that's going to be -5 right there, because you're replacing just the b with the -5, so that extra negative stays there. Plus or minus square root. Make sure you put some parentheses around this -5 right here when you square it, because if you don't, you'll get the wrong answer. Minus 4 times 1 times -8 all over 2 times 1. Now, you can get a decimal answer for this from Desmos. By just typing the whole thing in. So I would have, you don't have to put the x equals, just do -5. Actually, I need to do division here. Okay. Ooh, not there. That just be in the top. -5. You cannot type a plus or a minus in. You're going to type a plus first, square root of -5 squared minus 4 times 1 times -8 all over 2 times 1. Okay, it gives you a decimal. One of the problems is if it's a square root answer, a lot of times they don't give you a decimal answer. You also, to do the minus, like since it's plus or minus, you would do this once with a plus, once with a minus. You can copy and paste that there. And so these are your two answers. If they're wanting decimal answers, you can just write x equals, 6.275. And then you could also do x equals -1.275. There. However, a lot of times they don't give the decimal answer. So another way that you can do this if they don't give the decimal answer is only simplify what's under the square root. So like I've got a -5 here, that's going to become a +5. I will have plus or minus square root. And then I'm going to do 5 squared minus 4 times 1 times -8. So -5 squared minus 4 times 1 times -8. Don't put the square root, just the stuff under the square root. I'm getting 57. And it's all over 2. The square root of 57 will not break down, so you could just leave it like that. There. So it could be, you could give these answers, or this is really 2 answers here because it's 5 plus the square root of 57 divided by 2, and 5 minus the square root of 57 divided by 2 for that. These would be your zeros here, or your solutions. Okay. Do you guys remember doing that? Okay. It may come up a little bit where we have to use it to like finish out a problem for these. So let's look at this one. All right, so if I am supposed to find all of the x-intercepts for the function below, when I see x-intercepts, that's the same as zeros, right? Those mean the same thing. So if I want to find the x-intercepts, I could go over to Desmos and I could graph it. So I got 2x minus 3. I don't know why I didn't put my g of x there. G of x equals 2x minus 3. And x to the second minus 4x minus 10. Okay? And x-intercepts are going to be at negative 1.742. So x equals negative 1.742. They're going to be at 1.5. And 5.742. Okay, yes.
Can there be more than like 3 x-intercepts?
There could not be on this one because remember our rule that you can only have the number of zeros of your highest degree. Now this one looks like your highest degree is squared because it has this x squared here, but it's not been multiplied back together. So like if we went and like made the box and multiplied this back together, we'd have to do a 2x times an x squared, and that'd give us x to the third power. So this is going to be a third degree equation right here, so you're only going to have 3 answers for this. You could have fewer if it was like a triple root or a double root somewhere, but that doesn't happen on this one. Now, this works well if it's multiple choice. You could even take your answer choices, type them in, and see if the decimals match. There are a few ways that they might give you this equation that you would need to be able to do it by hand, okay? So if I were doing this by hand, I would do the same thing that I did on the earlier ones. I would just take the pieces, 2x minus 3, set it equal to 0, and I would take x squared minus 4x minus 10 and set it equal to 0. So for that first one, Scarlett, what would we do to solve that first equation? Good. So I'd have 2x equals 3. And then what would I do after that, Scarlett? Perfect. And so I would get x equals 3/2. And which answer is that the same as? Over here. It's 1.5. 3 divided by 2 is 1.5. So that would be that answer. Now, this answer, it looks sort of like it will factor, but if I tried to factor it, the only things I can multiply to get negative 10 are negative 1 and 10, 1 and negative 10, negative 2 and 5, and 2 and negative 5. Do any of those add together to give you negative 4? They do not. So what you have here is a quadratic that will not factor. So no matter how hard you try, you can't get it to factor. So when that happens, that's when we've got to use the quadratic formula. So for this quadratic formula, we would have a 1 right there. Our A would be 1. Okay, so we'll have x equals negative b. B would be our negative 4. Plus or minus square root negative 4 squared minus 4 times A, which is 1, times C, which is negative 10, all over 2 times A, which is 1. And if I'm going to do this one without the calculator, like it's one, if I'm doing it by hand, it's probably because they didn't give me a decimal answer. So let's do this without doing the decimal. So negative 4 is a positive 4, plus or minus. And then we've got square root, and I'm going to type that into Desmos there. Drag this over this way. We're going to get negative 4 squared minus 4 times 1 times negative 10. And we get 56 right there. All over 2. Didn't mean to make my square root so long. That was unnecessary. Now, on this one, I think square root of 56 breaks down. I think you can divide that by 4, which is 14. So, I don't know if you guys remember doing this. Square root of 56 is the same as the square root of 4 times 14. You can take the square root of 4. What is the square root of 4? 2. So that would be 2 times the square root of 14. So I could write it this way. 4 plus or minus 2 square root of 14, all divided by 2. And then that will reduce there. So 4, 2, and 2 are all divisible by 2. So you would have 2 plus or minus square root of 14. It'll all be over 1, but you don't have to put over 1. All I'm doing there is taking all of these numbers right here, dividing them by 2. So 4 divided by 2 gives me that 2. I divide this 2 by 2. It gives me a 1, which I don't have to write, and I'm dividing this one by 2, which gives me 1 on the bottom, which I also don't have to write. You don't divide what's under the square root there when you're reducing. Most of the time, you can do this with the decimals. Most of the time, you don't have to know how to simplify that quadratic equation, but there are some ways they could ask you a question where you need it. Okay, now, these are still, even though they're crazy answers, they are still real zeros. Because the answer is a real number that does not include I. Okay, so all 3 of those answers are still real answers. You got square root of 3 over 2 and 2 plus or minus square root of 14. Those are real answers there. Yes. It would be used to solve a polynomial equation. So you would first of all have to find yourself in a situation where you've used like a polynomial equation to set something up. We'll look at a couple of like word problems in the next unit. That'll give you like a little bit of a scenario. But this is used to solve, which would give you like the answers that you're looking for in a different scenario. It is going to be a rather like complex scenario that you're looking at. So this is not something that would be like a daily basis sort of thing. But if you are modeling is where it's going to come up the most. Like if you are looking at patterns in something, so if you were researching something like the spread of a disease or something like that, you might use something down this line here. Okay, let's practice a little bit of simplifying radicals, okay? Because you do simplifying radicals a little in Math 1, a little more in Math 2. I also realize you may or may not remember how to do a lot of it. Plus, I don't think you guys did much with I's. So you will need a little bit of instruction in what to do with an I. Because we're expected to do those imaginary numbers some too. All right, so I am hoping we can answer number 4. What is the square root of 25? It is 5, right? Because when we are doing a square root, we're asking ourselves, what times itself gives me that number? So if I want the square root of 32, I'm thinking, what number times itself gives me 32? Is there a number that does that? There is not, because if I think of the perfect squares are the numbers that I can take the square root of, right? So 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. I'm going to stop there, but they keep on going, right? We could do 13 times 13, 14 times 14, 15 times 15. I don't really expect you to know those because when you memorized multiplication tables, you probably stopped at 12 for those. So these are our perfect squares. We're going to use those to help break down square roots, okay? So we could type square root of 32 in. It will give us a decimal approximation. That is not exactly the right number. It is a decimal approximation, which is close. That number keeps on going forever. So you can't, even if you keep 15 decimal places, it's still not the exact value of square root of 32. Most of the time, it will be close enough to do whatever you are doing. But sometimes there could be instances where you need to be more accurate. For example, I remember, I need to go back and look up the article, but I remember reading about a situation where there was like a NASA launch that they were doing where they had miscalculated something about the trajectory of the satellite or whatever they were sending out into space by like that they were like wrong in their like 8th or 9th decimal place, way out there, and it ended up putting the rocket like way off, like, you know, thousands of miles off track, which did no good. Because it was very, very, you have to be very precise in that scenario, because when you start sending things out into space, you're talking about thousands of miles, and eventually you even start talking about light years because it's too many miles to talk about. So if you're off by just a teeny tiny bit, that error gets multiplied and makes a big difference. So, you know, there are scenarios where we want to be really, really, really precise and want to know the exact decimal. I don't know that any of us in our real lives are going to run into a lot of those scenarios, but they do exist. And that is one of the reasons that we teach you how to simplify radicals for this. It's a very mathematical thing that helps you in like higher level maths here. So square root of 32, we cannot take the square root of 32. But if I start thinking, is 32 divisible by any of these numbers over here? Is not divisible by, well, 5 is not one of my perfect squares. I heard 4 and I heard 16, and both of you are right. You want to use the biggest number that it's divisible by. So 16 would be better than 4 here. So 16 times 2 equals 32. So I could rewrite this like this, square root of 16 times 2. And now I can take the square root of 16. Because when I'm looking at this, you could break these apart. It's like square root of 16 times the square root of 2. The square root of 16 is 4. It does not need a square root anymore there. Square root of 2, you cannot do. There's no number times itself that gives you 2. So you would just leave it underneath the square root. So square root of 32 could be simplified into 4 square root of 2. I know that doesn't even really seem like it's much more simple, but in some higher level math that you get to, it can help you in simplifying stuff there. Now, let's talk about this one, square root of negative 16. Now, if that was square root of 16, it would be easy. What would the answer be? 4. But it is negative 16. Is there a number times itself that will give you negative 16? There is not, because if I try to use a negative number, negative 4 times negative 4 is still positive 16, right? So we learned the other day that the square root of negative 1 is a problem, and we are going to try to fix that problem by calling it I, right? So when we have a negative, here's what we're going to do. We're going to break this up. We're going to call it the square root of 16 times the square root of negative 1. And 16 times negative 1 gives you negative 16, right? So this is still equivalent. And it breaks it up where we can deal with this. So square root of 16 is just 4. I can take the square root of positive 16. And the square root of negative 1, I could leave square root of negative 1, or we gave it a special name. We call it I for that. So square root of negative 16 can be called 4i. Okay, now I've got negative 150. Is 150 a perfect square? It is a number of times itself. It's not. So this one's going to have to be broken down. I know I'm going to need a square root of negative 1 because I got a negative number. 150. Which one of our perfect squares will go into 150? 25, right? So 25 times 6 is going to give us 150. So we could do 25 and we could do 6. So when we do this, the square root of negative 1, what is it? I. Square root of 25 is 5. And square root of 6, we don't have one, right? We just got to leave it underneath the square root. Most of the time they will rewrite this like this. They'll put the 5 and then the I and the square root of 6. They usually put the number first there. Now these first two you can kind of check on Desmos to see if you're right, because if I type square root of 32n and 4 square root of 2n, I can see if they equal the same thing. If it has an I, it's not going to do that in Desmos, so you have to know how to simplify those. And this is also important because if it has an I, is it going to show up on the graph whenever we graph it? It will not show up on the graph. So these, you have no choice. You are going to have to do them by hand for that. There's not going to be a shortcut for those. But I could give you really terrible ones that are really difficult. But I'm not going to give you super difficult ones. They are mostly going to be pretty straightforward. If I give you one like number 8, I could graph this and it will find 2 of the zeros. But there are going to be 2 zeros it does not find because they are imaginary. So this is one where it's really just going to be better to start off doing it by hand. So this one's already factored. They're asking me this time for the roots. What are roots? There's a bunch of names for the same thing. They are zeros or x-intercepts, right? It's a bunch of names for the same thing. So if you see roots, zeros, x-intercepts, all of those are asking for the same thing, okay? So if I want to find those, I need to figure out what will make this 0, and since it's already factored, I can just set the pieces equal to 0. 2x minus 1 equals 0, x minus 5 equals 0, x squared plus 25 equals 0. So, Kama, what would I do to solve that first one? Good. We'll add the 1. We'll get 2x equals 1. Then what would I do? Divide by 2. So I will get x equals 1/2. There's one of my answers for that. Let's see. Maya, what do I do for the next one? Just add that 5. This is the easiest of all of them, right? I'm just going to get x equals 5. That'll be one of my answers. All right. Jonas, what do I do for the last one? Very good. We'll subtract that 25, so I'll have x squared equals negative 25. Okay, then what do I have to do? I think I heard it. Square root. We got to square root it. So to get rid of a square, we have to square root. Now, here's where we run into an issue. First of all, this is a rule from solving quadratics. If you take the square root of both sides, you must put a plus or a minus right here. Okay. Now, I am taking the square root of negative 25. It is going to be 5i. Because Square root of 25 is 5, but since it's negative, it's got to have that I with it, okay? Now, that is actually two answers, right, because of the plus or the minus. So you can list them together like that, or you could do x equals positive 5i and x equals negative 5i. Either one, like together with the plus or minus is fine, or separate like that. It might be helpful to list them separate to recognize they're two different answers, and you actually have 4 answers total for that. So you would have 2 real zeros. Those you could find from Desmos. But those 2 imaginary zeros, you're going to have to be able to do by hand for that. Okay, questions? All right. This last one right here is the hardest one that we're going to do. So, this one, if they give you something like this, is not factored. So we can't do it by hand. We can't do it right away by hand. But if we do it with Desmos, at least I think that I have made it this way. Let's try typing it into Desmos. Y equals 2x to the third minus 4x to the second plus 16x minus 32. Now, if I'm pretty sure, if I type that in right, it looks like there's only one real zero for that, right? And it looks like it's at 2. So, it looks like I have a real zero at x equals 2. But if this problem has asked me for all of the zeros, I need to know the imaginary ones as well. Okay, so like I said, this will be the hardest type that you've got to do. If you have x equals 2 as a zero, that means x minus 2 is a factor. So here is what you're going to have to do. You're going to have to use that long division. So we'll have to put x minus 2 out here. And we'll have 2x to the third minus 4x squared plus 16x minus 32. So I didn't teach it to you like just for fun. You do have to use it to solve these sometimes. All right, so long division. What number times x would give me 2x to the third? I need 2x squared, right? So that means like over to the side, I'm going to have to do 2x squared times x minus 2. And that is going to give me 2x to the third minus 4x squared. So that goes here, 2x to the third minus 4x squared. Okay? And so then I will subtract, and this will cancel. This becomes like a positive. This also cancels, right? And then I will bring down 16x. I'm going to go ahead and bring down that minus 32 as well. So now I've got to start dividing again. What number times x would give me 16x? Just a positive 16, right? All right, so if I do 16 times x minus 2, I'm going to get 16x minus 32. And you'll notice that's the same thing as what you've got there. So when you subtract that, everything cancels and it just goes evenly. So that means this could be factored like this. Y equals x minus 2 times 2x squared plus 16. Now, once I have it factored, I can set each piece equal to 0. So I would say x minus 2 equals 0 and 2x squared plus 16 equals 0. So for that first one, I would just add 2, and I would get x equals 2, which is that answer we got looking at Desmos. That's my real 0, the one that I can see. But over here, on this side, this is where our imaginary 0 is going to come in. So, Riley, how would I solve that one? Good, we'll subtract 16. So 2x squared is going to equal negative 16. What would we do next, Riley? We're going to divide by 2 on that one. And I'm running out of room, so I'm going to go up here. X squared equals negative 8. And then we'll square root. And can I take the square root of negative 8? I cannot. I could break it down, though. I could make it square root of negative 1 times square root of 4 times the square root of 2. And square root of, that's a negative 1, although it looks like an H in my, let me just rewrite that, square root of negative 1. So square root of negative 1 is what? I. Square root of 4 is 2. And we cannot take the square root of 2, so we just leave it alone. They are probably going to write this as, and I should be putting a plus or minus here, plus or minus 2i square root of 2. That's actually two different zeros because it's a positive and a negative of that same value. There. So if you see one that's asking you to do zeros and it's not factored, graph it in Desmos first to find your real zeros because it probably has at least one real zero. Then, if it's got imaginaries, you are going to have to do long division on that. Okay. Questions? All right. I think we got one more here. Okay. All right. For this one, which graph could show this equation? All right. You definitely can graph this in Desmos. That's a perfectly valid option. Let's also look at how to do it without Desmos. If we do this without Desmos, and I want to see x-intercepts, my zeros, right? I'm going to have x minus 3 equals 0. That's just going to give me x equals 3, right? I'm going to have x plus 1 squared equals 0. That, I'll square root both sides. It's just going to be x plus 1 equals 0. I'll subtract that 1. X equals negative 1. For both of those, you can basically take the opposite sign. So that means we should be crossing the x-axis at 3 and at negative 1. And when I have a square right here, it means that we're going to have a double root right there. What do double roots look like on the graph? They just barely touch and go back down, right? At 3, we should cross, but at negative 1, we should touch and go back down. So let's look at our options right here. This is negative 1, this is 3. What does it look like both of those are on this graph? Those are both bounces, both of them double roots. What have you been making, Luis? Oh.
But, you know, it's sugar slushy.
Yeah. Well, it's okay. Thank you. He's not allowed to bring you one, sorry. All right. Let's look at this one. At negative 1, is that a double root? No, it does not bounce. But it is at 3. Is that the right graph? It is not. It has the right roots, but the wrong one is the double root. How about this one? We got negative 1. We got positive 3. Yes, that one is the correct graph, so we can use that. You can also graph it on Desmos and look at it there. Okay? You don't even have to worry about the imaginary roots here. You're going to get imaginary for that one, but you don't have to worry about it. Alright, so